Ever pondered what rain might be like on other planets? It's a fascinating question, isn't it? Here on Earth, we're quite familiar with the concept of rain. You might be looking out your window at a downpour right now, or perhaps you're remembering the gentle pitter-patter of a drizzle against your umbrella from a walk earlier today. Rain on Earth forms from water vapor in our atmosphere. When this vapor cools and condenses, it turns back into liquid water, forming droplets that grow and grow until gravity pulls them down as rain. It's a beautiful, natural process that contributes to the Earth's water cycle, nurturing our ecosystems and providing us with much-needed water. But let's leave our cozy blue planet for a moment and embark on an imaginative journey across our solar system. The planets and moons that orbit our sun are a diverse bunch, with atmospheres and conditions wildly different from our own. So, what happens when it rains on these celestial bodies? Is it the same gentle shower we're familiar with, or is it something entirely different? Well, spoiler alert, it is different. In fact, it's so different that it might stretch your understanding of what rain even is. We're not just talking about a little drizzle of water here and there. No, we're venturing into a realm where rain takes on entirely new forms, composed of materials that would seem outlandish and even impossible here on Earth. Imagine, if you will, showers of sulfuric acid, downpours of methane, or a mix of ammonia, water, and hydrogen sulfide falling from the sky. Sounds wild, doesn't it? But that's the reality on some of the planets in our solar system. From the sweltering heat of Venus to the icy cold of Uranus and Neptune, from the gas giants of Jupiter and Saturn to the intriguing moon of Titan, each has a unique version of rain. So, if water forms rain on Earth, what might form rain on other planets? Stick around as we delve into the mystery of extraterrestrial rain. Imagine a world where it rains sulfuric acid. Welcome to Venus. Venus, our solar system's second planet, is shrouded in a thick, heavy atmosphere composed largely of carbon dioxide, with clouds full of sulfuric acid. This isn't your typical earthly forecast, folks. This acidic environment is a result of a runaway greenhouse effect, where the planet's heat is trapped by its dense atmosphere, leading to scorching temperatures that could melt lead. The rain here doesn't fall as it does on Earth. Instead, sulfuric acid droplets form in the upper atmosphere, creating a dense, yellowish cloud layer. But don't expect these acid droplets to hit the surface. The intense heat of Venus evaporates the droplets mid-fall, creating a perpetual cycle of evaporation and condensation. It's a harsh, unforgiving environment that makes Venus the hottest planet in our solar system. So, Venus proves that not all rain is as refreshing as it is on Earth. Next, we venture into the realm of the gas giants, Jupiter and Saturn, where it rains something entirely different. Let's start with Jupiter, the largest planet in our solar system. Its atmosphere is composed mostly of hydrogen and helium, but it also contains traces of other compounds, including methane. Now, imagine a downpour, not of water, but of methane. It's a concept that might seem alien to us, but on Jupiter, it's just another day. The methane in the atmosphere of Jupiter condenses into clouds, which then create methane rain. This methane rain is particularly prevalent in the storm known as the Great Red Spot, a tempest larger than our own planet that has been raging for centuries. Now let's journey a little further out, to the ringed beauty of our solar system, Saturn. Like Jupiter, Saturn's atmosphere is primarily composed of hydrogen and helium, with a smattering of methane. Due to the lower temperatures in Saturn's upper atmosphere, methane gas can condense into clouds, which then produce showers of methane rain. These methane showers fall into the deeper layers of Saturn's atmosphere, where they eventually evaporate back into gas before reaching the planet's core. Interestingly, even though these methane downpours occur, they don't result in a methane ocean. The methane raindrops evaporate before they hit the surface, creating a cycle of evaporation and precipitation that keeps the methane in the atmosphere. So, if you ever find yourself standing on Jupiter or Saturn, don't forget to bring an umbrella. Not to keep yourself dry, but to shield yourself from the methane downpours. You won't be splashed with droplets of water, but with a rain of methane, a substance that on our own planet is a gas, but out there, in the chilly realms of the gas giants, takes on a liquid form. Thus, in the world of gas giants, rain takes on a gaseous form. Now, Let's journey to the ice giants, Uranus and Neptune, where the rain is a cocktail of elements. In the chilling depths of our solar system, far beyond the reach of sunlight, the twin ice giants Uranus and Neptune hold sway. These gas giants, while seemingly serene in their blue-green hues, experience weather patterns that are nothing short of otherworldly. The rain on these planets is a tantalizing mix of ammonia, water, and hydrogen sulfide, a stark contrast to the familiar water droplets we are accustomed to here on Earth. How does this unusual rain form? It all begins with the atmosphere. Uranus and Neptune both possess thick atmospheres, teeming with a trifecta of ammonia, water, and hydrogen sulfide gases. These gases, when cooled to extreme temperatures, condense and form clouds. The clouds, much like the ones we see in our sky, eventually get heavy with these condensed gases and release them as rain, plummeting towards the planet's cores. Interestingly, the rain on Uranus and Neptune doesn't fall in the same way it does on Earth. Due to the intense pressure and temperature changes in the lower atmosphere, the raindrops transform as they descend. Ammonia and water, under these conditions, form a hot, dense mixture known as ammonia-water ocean, blanketing the core of these planets. On the other hand, the hydrogen sulfide, with its unique properties, behaves differently. As it falls, it undergoes a phase transition and forms what scientists call hydrogen sulfide ice, adding yet another layer of complexity to the weather on these icy giants. And there you have it. The rain on Uranus and Neptune isn't just a simple affair. It's a symphony of elements, a dance of gases and ices, all playing out in the extreme conditions of these distant worlds. It's a reminder of the incredible diversity of our solar system and the fascinating phenomena that await us beyond our terrestrial confines. On Uranus and Neptune, rain isn't just one substance, but a mixture. Finally, we touch down on Titan, Saturn's moon, where it rains another gas. Titan, the largest moon of Saturn, is a world of its own, a place where it rains not water, but methane. Now, methane is a gas we're quite familiar with here on Earth. It's the primary component of natural gas, a common fuel source. But on Titan, it plays a role similar to water in our own environment. Here's how it works. Titan's atmosphere is thick and chilly, with temperatures plummeting to around -290 degrees Fahrenheit. At these freezing temperatures, methane, which is a gas on Earth, becomes a liquid. It's this liquid methane that forms clouds in Titan's atmosphere, much like water vapor does here on Earth. These clouds of methane, driven by Titan's weather patterns, can condense into droplets and fall as rain. Now, imagine what it would be like to witness rain on Titan. It wouldn't be like the rain showers we're used to. Instead, you'd see droplets of methane falling slowly due to Titan's low gravity, a sight that would surely seem otherworldly. This methane rain is essential for shaping Titan's landscape. It carves river channels and fills lakes, creating a network of liquid methane rivers and lakes across the moon's surface. It's a world that mirrors Earth in some ways, with its own version of a water cycle, but with methane instead of water. Interestingly, Titan is the only place in our solar system, apart from Earth, known to have stable bodies of surface liquid. But instead of water, these are lakes and seas of methane and ethane. Even more fascinating is that scientists believe that this methane cycle could support a form of life. Not life as we know it, of course, but rather life that thrives in extremely cold temperatures, using methane instead of water. So on Titan, it's methane that falls from the sky, not water. As we've journeyed through our solar system, we've seen that rain takes on many forms. From the acidic showers of Venus, comprised of sulfuric acid, to the methane downpours on gas giants Jupiter and Saturn. Each planet presents us with a unique and fascinating meteorological phenomenon that defies our Earth-centric understanding of rain. Even the ice giants, Uranus and Neptune, offer their own cocktail of precipitation, a blend of ammonia, water, and hydrogen sulfide. And let's not forget Saturn's moon Titan, with its lakes and rivers filled by methane rain. The diversity of rain across the solar system is a testament to the myriad of ways that atmospheric conditions and chemical compositions can interact to create weather. So next time you find yourself caught in a downpour, remember, at least it's not raining sulfuric acid, methane, or a cocktail of ammonia, water, and hydrogen sulfide.